Hello, I'd like to kick it off with a quick showing of hands. Who wishes that they would have worn more comfortable shoes? That's awesome, that's a lot of people. Who wishes that they had a lighter backpack? Mine feels like 2 bowling balls. My name is Jason Barrios. I'm a principal solutions architect here at AWS. And excuse me while I grab the remote. I'm joined by Jose Thomas and Vikram Krishnamurthy,
Yeah, you got it.
both senior software engineers at Netflix. I'm not nervous at all, you can tell, right? As most of you can probably imagine, Netflix manages hundreds of petabytes of media assets through their entire life cycle. In this session, you're going to get a peek under the hood at their storage access strategy and powerful automation engine. With that, I'm going to hand over to Vikram.
Thank you, Jason.
Right. Thank you, Jason. Hello, everybody, and welcome to our talk, NFX203. And as Jason said, we'll be talking about a homegrown cloud file system that we built. And just a bit of a rewind. Last year, we spoke about this file system exclusively. It's called Netflix Drive. And this year, we've come back to talk about how we've been using it at Netflix. And we picked a couple of case studies, 2 use cases. So I'll structure this talk by dividing it up into 4 sections. I'll give an introduction. Even though we had a long talk last year, I'll kind of give an intro, because some folks may be new. I'll go over it. And I'll talk about the aspects that will be relevant to the case studies. And then the next 2 sections, I'll hand it over to Jose for the first case study, and then we'll be going back and forth, so bear with us. 2 case studies, and then finally concluding remarks and Q&A. Okay? So let's get started. What's Netflix Drive? So we'll cover the what and the why, and then the how, and then we'll get to the case studies. So it's a multi-OS and a multi-interface cloud file system. And I'll get to the multi-interface part in the subsequent slides. Multi-OS is kind of, we support Linux and Mac OS and also Windows. And it's supposed to be a seamless abstraction for object stores. So I've called that out here because it's relevant to the case studies, but it need not be just object stores. It can be an abstraction to any kind of stores. And I'll get to some of those details in the subsequent slides. So on Linux, it is Fuse-based, Linux and Mac OS, it's Fuse-based. Fuse is a file system, it's in user space. It's an abstraction and a library that's available, open source library that's available for implementing custom file systems. And there are a lot of open source file systems based on Fuse. And there's a similar interface on Windows, which hooks into the Windows kernel. It's called WinFSP, but has a Fuse abstraction layer as well. So in addition to that, we also have an API interface. So it's kind of a service endpoint as well, in addition to being a file system interface. And it supports a variety of data and metadata stores. And I'll get the subsequent slides when we walk through, I'll get into the nitty-gritties of those things. So the why part of it, motivations. Why did we build this? So at Netflix, like Jason introduced, we have petabytes of media assets floating over. A lot of legacy systems and systems that evolved and kind of sitting in various stores and managed and controlled by various metadata stores. So we wanted a common access plane for all of this, wherein anybody or any application trying to get to a certain part of the assets don't have to worry about what metadata store it is under and where to get the data from, and those kinds of things. And typically, all of the studio or the DCC type applications, digital content creation applications, expect POSIX file and folder interface, as do the users, the artists and the VFX editors or whatnot working on those assets. So to kind of meet those needs, we came up with this common access plane, and we have implemented this file system. And we also have a need to move these media assets. So the petabytes of assets we talked about earlier are not static. And as they come off the camera, they kind of move through various stages of production, post-production, VFX editing, all of those good things till it makes to the streaming end. So we needed a way to move them seamlessly and transparently across these various stages of workflow. And on top of all of this, we also wanted good and easy and common access control mechanisms. So a file system probably provides all of this, and we can control how we implement it, how we enforce it. So that kind of gave us the a solid need to come up with this Netflix Drive. So the next few slides will go a little under the hood and look at the architecture, and which kind of shows how we are addressing all of the. You have a question?
Why ephemeral? What do you mean by ephemeral?
So based on project needs, let us say there's a movie or a project that's currently being worked on by an artist. So that artist gets access to that particular set of assets at that time, and then the same artist may be working on a different project or movie. So it moves around, right? So that's the sense in that sense. So thanks for the question. Yeah. Okay. So I said multi-interface. So we have the POSIX, the standard POSIX interface on one side, which is standard on think of on the Linux side, the VFS, the file system call type interface. And I also mentioned about the API interface. So that's kind of a control and a controlled I/O interface to access these assets. And I'll tell you, and we'll get to how it's used and how it's leveraged in these use cases. And then we have a transfer plane, which is in charge of transferring data to the various backends that we talked about, maybe object stores or any other kind of data stores. And we also have an interface that emits events, logs, and metrics for tracking, monitoring the application. So the POSIX interface is pretty standard. All the file system calls, read, write, create, open, close, delete, either initiated by user actions explicitly or indirectly through applications opening files and working them, saving them. Or it could be some agents or workflow tools that operate on these files. So all of those go through the POSIX interface. This will be on the workstations, let's say. And so this is slightly different and distinct from a typical cloud file system, which we don't see most of this kind of an interface, the API interface I'm talking about here. So this allows workflow tools and agents to have a richer control over creation of namespaces, as one example. And we'll get to that in the case study, one of the case studies. Or to control when the files that are modified get synced back to the cloud, or to what assets to bring down, create a namespace dynamically. So this interface is intended for that, and it helps us to integrate it seamlessly into these workflows. Moving on. So events, audit logs, and updates. So these are logs and metrics are more for self-serving and monitoring observability kind of a need. And we have updates and audit logs to track if there is a need to the states of assets, if there is any special handling or tags that are applied, and any state changes that applications can control and will be useful in the different stages of the workflow. So that's what it's intended for. And all of these kind of end up in the cloud, in the AWS cloud. So. Okay. And finally, the actual byte movement. This happens through the abstracted data interface. And so we use a local store to give near local file system performance because applications like that and artists expect files to load quickly so they can work on it, and then it's saved locally as well. So it doesn't have to go to cloud for every save click. But it can be thought of as a tiered cache to the actual source of truth, which is the cloud storage. And we could also use intermediate caching tiers in the cloud itself, depending on like if there is a need to have something closer to the region where the artist is, things like that. So the main idea here is the abstractions that we have kind of allows us to plug in any kind of backend, and these are some of the examples we have. So finally, like the grander unification of all of these aspects kind of gives us Netflix Drive, the operational state of it. You can see that here. This slide is a different view of the same system. So it kind of opens up like kind of the under the hood view. Gives you the layers and the modules within, roughly the logical modules, think of it as that makes up Netflix Drive. So we have the fuse handlers and the REST endpoints that kind of give us the interface layers. And on top, those layers in turn interact with the abstractions I talked about earlier. So we have abstracted metadata interface, data interface, and a security interface. So this allows us to use any or bring together different metadata and data stores together, and also if they have a separate security or access control service or endpoint that they use, tie it all together and kind of give it a unified look and feel and present it as a namespace hierarchy. And then the underpinning of that is transfer service. So that's kind of a quick overview. I kind of rushed through it because we wanted to give time to talk about the case studies and also any questions. So if you have any more questions and details, we do have a blog post. I'll show there's a link at the end, and we can also discuss after in the Q&A section. So I'll jump into the first case study here and get to the motivations of this. Going back, so it's media workflow orchestrations. That's the case study here. And so this is an example where we have no user interacting with Netflix Drive. It's an automated deployment, and it's kind of embedded into a workflow pipeline. And I'll let Jose take over, and then he'll talk more detail about this.
Thank you, Vikram. Yeah, so I think like Vikram mentioned, I think the last time Vikram was here at reInvent, we talked about NDrive. But over the last year, what we primarily focused on was actual use cases, and this Studio Orchestrator use case is one of the, very heavy use of NDrive in a very programmatic way. It's like there's no user there. It's all basically media file manipulation that kind of happens on the side, in the back end, And Studio Orchestrator, for those who might not be familiar with that term, is basically a platform that we built at Netflix to automate and power a lot of the, processing that happens within productions. And I know at least one face I see from a previous talk I had a couple of days ago about this topic. So Studio Orchestrator is this platform, productions. I mean, when I say productions, I mean, content production groups like, doing movies, series, those kind of people. They can write workflows on top of it, pipelines on top of it to automate, media processing. For the sake of this, for this talk, I'll, mostly talk around VFX inputs processing, before a VFX artist does their work, they get their source material. There's a bunch of prep work that kind of needs to happen before an artist can work. In many studios, this is kind of done manually, but we have automated a lot of it so that the artist can really focus on the creative, and whatever the machines can do for them, we do it using the Studio Orchestrator. Okay, so in this case, where we have these VFX source files coming in. We are doing a lot of these pre-prep work. What happens first is, you see at the bottom of the slide the control plane, which is this Orchestrator, which whose job it is to gather all the sources, lay it out in the way that the system expects, pathwise and all the necessary input that needs to be there. It assembles them. It does a bunch of other things, but for the sake of this, that's the key thing. It basically lays it out in the way that it needs to be. And then once it's all done, then it basically runs these media transformation processes in a little container cluster. It doesn't need to be containers, but that's what we happen to use currently at Netflix. And so in these containers, we have essentially NDrive running. And what we basically need to tell NDrive in this case is, okay, here's a bunch of objects sitting in S3. We have some metadata, of course, to determine and define how these need to be laid out in POSIX style path structures. And then with all that data, we let NDrive then pick it up, hydrate the files. Basically it pulls down whatever it needs to, and then the actual media transformation essentially happens there. And the media transformation, just so people can maybe identify with what I'm talking about, is like, so if you have original VFX source material, you cannot really play it on say a browser. So this may be, these kind of processes may include things like generating H.264 encodes, which you can then view on a browser, things like that, and several others, which I'm not going to get into. But those processes are now run on these single containers. And if you look here, we kind of show multiple, because these jobs can be parallelized in many ways. So in this particular case, we kind of take these what are called VFX shots, and we run each of them on like a separate container. And of course, at the end of it, new files are produced. And we again depend on NDrive to basically put them back in the cloud in a very well-known place. And even in that case, we retain the path structures and stuff like that, so it's usable in downstream processes. So as you can see, it's a very back-end kind of thing. There's no user interacting with this thing. So the key thing is, we need this fine control, and this is some of the APIs that Vikram mentioned, like the mount and adding files to it and so on. So all that power of that API comes into play here. So we can tell it exactly what to pull down, what it should put back to the cloud, and so on. Also, we want guarantees that the files are exactly copied back. Nothing is lost, no file is lost, because in these cases, we're actually talking about in each job several thousands of files. Usually because these are stored as frame files, a video as separate frames. So all those files need to be transferred and transferred accurately. We want to make sure that there's no data loss or corruption or anything like that. Of course, there's no absolute guarantees. If something fails, we need to be notified. That's the expectation we have of NDrive here. And just to peek under the covers, what you're seeing here is actually, I don't know if you're familiar, this is this Netflix open source the workflow thingy called Conductor, which is basically the underlying thing beneath the Studio Orchestrator platform. And what you see here is basically, how we, I highlighted, I know it's not a very pretty chart, but what I've highlighted is a task which actually does this media transformation process. So from a person who's authoring a task, a workflow like this, all they need to worry about is to say that, okay, here's my source, and here are my environment variables. Here's really my container, Docker image name and tag, and here is the command I want to run. And we do all the things necessary behind the scenes, including booting up NDrive the right way, giving it the right sets of configs, and then at the end making sure that NDrive has actually written back all the newly generated files. And then if you kind of zoom out a little bit, this is a higher level view of what's really happening under the covers. A lot of little green boxes there, so much so that you can really see all of them. And then even with a zoom, you can see how many of those really are in there. So each little green box that you see at the very lower level actually represents a job where NDrive was used. And as you can see, in this particular one, there's probably like close to 1,000. So we are able to do all these several containers in parallel. This is basically one job at the high level. This is a case where one set of VFX source material came in. We basically parallelized the entire job, distributed it in the cluster. Everything came back, and the job is all green. Everything's done. It says complete over there. So yeah, the key thing here is we are able to parallelize them. Of course, there are different levels of parallelization. Of course, you can even go down to very minute levels, but we kind of stay kind of at a higher level. We'll do it essentially at a VFX short level in this case. But the pipeline, of course, makes sure that every single task completes successfully, and if it fails, it does what it can to recover. Sometimes there's some automatic retries, things like that. Or if it fails, maybe some human intervention might be required. And ultimately, it'll collate all the jobs, and it's all good. That's the function there that the Studio Orchestrator plays. So here, the key thing is from the developer of the workflow, in this case, perspective, they can operate as if it's like a POSIX file system. Here, the tools that get used to do these sort of generations, these kind of transformations, are standard off-the-shelf digital content creation tools like Nuke, Maya, which is commonly used in the industry to do visual effects and things like that. So yeah, the NDrive's POSIX interface comes into play, and those aspects is what make it very usable in this kind of use cases. So Vikram, over to you to pick it up from here.
All right. Thanks, Jose. So yeah, to kind of continue here and give more flavor. So the other thing is the ecosystem that artists and editors use on their workstations and tooling. Typically in the studio, I think we've seen that they're used to those things and they don't like anything new or different. So this, having this Netflix drive and POSIX interface gives them an ability to have the kind of reuse those tooling as is or with minimal change. So that's another aspect here. Let me kind of address this bullet points in another way. Kind of let's look at what would we need if we did not have Netflix drive and the rich control plane interface that we have, right? So every use case like this one would have to deal with the complexities of locating the assets, downloading them, and making sure that the state changes, tracking the state changes, and figuring out how and when to upload them back to cloud. So it will be kind of repeated all over, like for every different use case. But with these things hidden and exposed as APIs through Netflix Drive, all the tooling and the agent that has to do is just worry about the IDs and the locations that Joe showed in one of the earlier slides. They just need to have those well-known identifiers or whatever way they are organized, and then have them projected onto the container or workstation or whatnot. So it kind of makes it pretty seamless and repeatable for different use cases. And also, having a file system kind of gives us the ability to control and optimize how and when we upload data back and avoid repeated uploads, because an artist can be kind of clicking save. Not this use case, but the next one we talk about. They may hit save multiple times, but we don't want to upload to cloud every one of those times, right? Just because this will change. So that kind of concludes the first case study. And this second one is a different flavor. So this is an artist working on their workstation, virtual or physical, does not matter, and how they interact with an asset. So it's kind of the other extreme. So first one we saw automated programmatic embedding in the pipeline. So this is more of a edge, or not really an edge, but closer to the artist use case. So this asset store use case has NDrive running on the artist workstation. And the way NDrive interacts is with through DCC software, or indirectly through that by the user doing some actions on that software. And so even this requires some kind of orchestration and control from the cloud. So we have the control plane running in the cloud. And in this use case as well, we leverage the studio orchestration engine, but in a slightly different manner. Here, instead of scattering the assets or thousands of frames across multiple containers, we are bringing a very specific set of assets or files that the artist wants to work on that particular day or for that work session. And that, again, is done through the control plane interface that NetFlix Drive has. And this also kind of gives us the ability to have a secure way of bringing it, and then making sure that the artist gets to see only what they are required to see for that work session. So for this use case, specifically, and then this can be generalized and kind of used in, repeated in other slightly different use cases as well. We needed a cloud storage access layer with a rich control plane, like I said before. And then we needed flexibility around file or project granular access. So we didn't want to give access to the entire set of media files that's sitting out in some backend storage. So we wanted a very specific set of files, maybe even like as low as just one per session for the artist to work on. And then also the ability to dynamically add a namespace, bring in a particular file or a set of files, and then tear it down, and then bring in a different set of files, all in like one, like as the artist is working on it through just a few button clicks, without the artist even knowing about what's happening behind the scenes. So again, the APIs are leveraged, and then there's a agent or a workflow tool that is aware of these APIs that runs on those workstations. And in this specific use case, we also required a need to sync to the cloud at very specific points when the artist is ready to publish the asset to the cloud. So we didn't want every save to go back to the cloud and create versions, because every publish event creates a new version of the asset. Okay, so we have embedded a demo. It's a video demo. It's not a live demo of exactly how these things happen. And it uses a tool that helps orchestrate and bring down the assets and create all of these under the scenes. So what you're seeing here is the artist interacting with that tool, but under the hood, it's NetFlix Drive bringing files. And I think there are some clips which shows how the mounting happens. Jose, you can talk about it.
Yeah, sorry, we cheated. It's not the real demo. It's going to be a video recording. We didn't want to tempt the demo gods here, I guess. So, so what we'll look at is it's a simulation really of an artist that might use NDrive to do their work. So what they may start their day with is this little application, this NetFlix application, which shows their workshop, is basically the things that they need to work on, let's say the artist, right? So in this case, we have this very pretty dinosaur that an artist is going to iterate on, maybe create some new versions and so on. So, so the artist may start here. And in this case, the artist may be actually, not in any facility or anything like that. They could be at their home. They could be at a coffee shop, wherever. But they are able to do their work anywhere. That's key, because, this is to sort of allow that remote work capability. So they would start here on their Mac, not like a cloud computer. They come here, they can then, what you see here, what you'll actually see in this video is actually the artist using Photoshop to edit a PSD file. And in this interface, what you're seeing is really a thumbnail of that in a JPEG form or something like that. So the artist can then, come here and then they click it. And once they show the intent to start working on it, that's when NDrive comes into play. Imagine NDrive is already like running, it's mounted, it's there, but it's got an empty namespace. There are no files in it. What files go into it depends on what the user chooses. There could actually be more than one thing here. So like Vikram alluded to, at this point, depending on what the artist may click or select, the right files get landed or made available on the local machine. So that's what you're seeing here. You'll see NDrive mounted as that fuse mount down there, and that's the artist opening up Photoshop. And at this point, the file is already available, visible down on the machine, and it's a PSD file. You can open it up in Photoshop and start the iteration. In this case, of course, this is not a real artist. This is one of my intrepid colleagues, Gina's work here. But yeah, this is just to illustrate how an artist may iterate. So in this case, we're going to make a few different variations. Maybe to get input on, or maybe get the supervisor on the project to say, oh, okay, I like this kind of dinosaur better than the other. So we'll see the artist basically essentially creating a few iterations, a few different versions of the dinosaur. So let's say we give the dinosaur now these golden teeth, right? So and like Vikram mentioned, these files, the artist can save it locally as many times as they want, and it's durable. It's right there, and you get local file system kind of performance. And as far as Photoshop is concerned, it knows no better. It reads it just like a local file. And all saves are, actually on NDrive, but, it is local performance. But when the artist is ready to publish or make a version, visible to the external world, they do this operation of, a publish or a submit. So they can enter their nodes and click that button. It creates a version in our backend asset management versioning system. So obviously in this, what you're seeing here is the file is actually getting saved back into S3. Some metadata gets saved in like the asset management versioning kind of systems, which is Netflix proprietary systems. And those versions, or whatever the artist may publish, gets saved and tracked there. So that's what we see right there is the publish process. Yeah, so let's make the dinosaur a little more scary, make it look red. All those iterations can happen. And for good measure, maybe we should add some spikes on it, make it even scarier, hopefully. So yeah, I mean, this is just to illustrate that the artist can create multiple versions, save it locally, publish them as and when necessary, only when they want to. If it's not published, it stays essentially local, as in the artist doesn't need to, save intermediate work. So once the artist is done, without them really caring, these things are already in the cloud. So what happens is now if you go back to like the workshop view, we can now see all the versions that the artist actually created. So this is all happening sort of asynchronously. So the PSD files make it into the cloud. Then we have to run kind of transform jobs to generate PSDs out of it. So it's a little delay there. But yeah, these are now visible. And these are visible not just to that artist, it's visible to others on the team as well, maybe to the supervisor or whoever might be making decisions or comments on these kind of things. So at this point, yeah, these are, without the artist having to think about it, these are now available in the cloud. And that actually opens a lot of possibilities. So here, I think, yeah, we are now waiting for the last of the versions to generate its JPEG. So the thumbnail will then show up here. And also, if you look in NDrive, go browse to NDrive, basically, you only see the latest version, your current working version. But in the cloud, we've backed up and tagged and versioned up all versions that the artist chose to save. And this is where you see, just the last version is basically on the local. And if you refresh that now, yeah, the backend async things have generated the thumbnail for the browser view here. So that's in a nutshell what these NDrive backflows are capable. And as you can see here, from the very beginning, what file lands on the local machine to when they are flushed out into the cloud is all controlled by API. So you saw that little dialog that came up, and the user clicked publish. It's at that point that we tell NDrive, okay, write this file back out into the cloud, and the copy is kept there. So that amount of control is absolutely essential for these kind of workflows. And if you think from an artist's perspective here, artists don't care about cloud and stuff like that. They just want to do their artistry. They would just want to do their daily work. So for them, to give them a seamless experience, where they do work like they always do. You edit in in Photoshop, you save them, and go along with your life as usual. But ultimately, behind the scenes, all these things are being pushed to the cloud. And all of a sudden, now we have the capability of sharing it with people wherever in the world they might be. And a lot of VFX flows are really collaborative. And in today's, in the old way of doing things, people put things on on a shared drive, like an NFS or something like that, and a limited set of people can mount and work on them. But with these kind of flows now, you have the power of S3. You can have, you're not limited by a single NFS or a network kind of storage, which will have limits on how many productions can concurrently use it, how many users can use it. But now we have the full power and scale of the cloud, plus all the abilities to now share with people, collaborate with people, do like these collaborative workflows. Now somebody else can pick this spiky red dinosaur and now add the actual animation to it or whatever, right? So those kind of things can happen seamlessly and very easily. And that's where the power of the Studio Orchestrator plus the power of NDrive really comes to bear. I think I'll hand it back over to Vikram to pick it up from here.
Sure. Thanks, Jose. Yeah, so we kind of, our goal was to give 2 example use cases to show how it's used in very different ways, right? And so that hope we've brought that out in these 2 different types of use cases here. And so in concluding this, we're close to the end of the presentation. So I just want to say that we think we've created a configurable and adaptable access layer, which gives a rich control plane and also a standard file and folder access that users and applications can get to. And it is also suited for use cases where there is a need for local file system performance. That's where the local file store tier comes in. But it's not limited to that, though. These are the use cases that need that. But if there is a use case where there is no local store, or if there is a need to work on really large files that exceeds the container storage or the workstation storage, then the pluggable model I talked about, different backend adapters, gives us, we could use a streaming adapter probably to maybe stream directly to an object store, things like that. We haven't had a use case for that yet, but it allows us, the architecture allows us to do that. And also we're not using this as the one access layer for everything as an abstraction for S3 or cloud. If a use case requires access to a file server, EFS or NFS, we deploy that there. So we don't have to kind of force this everywhere. So we've been judicious about like where it can be used and it will be used. So typically we look for use cases where the control plane plays a role, and where the workflow tools or agents can leverage those APIs in the API layer. And it could also run in a headless fashion. So if there is a use case that doesn't require the POSIX interface at all, then it can just interact with the API layer and the API interface and work with files that way as well. So we wrote a blog last year before the reInvent. So that's the link to that one. And we're planning to write at least one or two more this year as well. We could not get to it before reInvent. Usually that's our practice, but this year it did not happen. So look forward to that.